All right, welcome to Database Development and Design at RVCC. This is our Chapter 1 Intro to Databases and Data Architecture. If you watched the earlier videos, we kind of get an intro of what we're doing here. Now it's just going to start teaching. I always like to start off with a trivia question. So you can play along. What real world object does this database icon represent? This is the common database icon. So you guys can pause it, play a little Jeopardy music in the background if you want, and go on. The answer is it's a hard drive. If you can look, this was the very first commercial hard drive available in 1956. This entire thing made a total of 3.75 megabytes of data stored on 50 large disks. Each one of these disks was the size of a large pizza. And these were platters, and they used to feed like an old jukebox, if you've ever seen one of those. But so this was the original hard drives. They were thousands of pounds and, not very good. But that's what they were, so that's where that comes from. All right, so we're going to go into Introduction to Databases and Data Architecture. We're going to start the course off by asking some questions. We should always ask, why do we have it? What is a database? Why do we need one? And what uses do databases have within business and scientific communities? Okay, so the very simplest thing I can say to you in databases is an electronic repository of data. This could be anything from just a collection of documents to a massive data lake. And another phrase they commonly use now, one of the most modern architectures, is called the data lake house. Most databases can be split into two main categories, structured and unstructured, also called SQL and NoSQL. We'll explain that in a little bit. Structured databases are also known to be relational, meaning they are a series of tables held together by relationships made of key pairs. And you'll get sick of key pairs by the time I'm done, but this is just the random meeting, and we'll get deeper into it as we go. Okay, so relational databases are the most common and generally what people think about when they hear the word database. Think of the Excel file, the two-dimensional table, as we call it. So some relationship basics we want to get into is the first thing is the database. A database is a collection of structured tables or objects designed to store data. It is not SQL Server. It is not Oracle. It is not terabyte data. You're going to find out those are management systems. They are not databases. We'll get into that. The base level here, what we're going to work on, is a table. So you see this whole thing, all these tables make up a database. Each one of these tables is a table. Okay, and that's normally it's everything object oriented into fields and rows, or fields and records, or columns and rows, however you want to say it. Both kind of interchangeably used. This is the two-dimensional view most people have of databases. So a field or a column in the database is called a field, each column, and a record, they're all called our rows. So this is the most basic level we're working at here, is just the table, which will have fields, columns, and records or rows. Now, while relational databases will be the vast majority of this course, it's important to remember there are other types of databases out there. For examples, the alternative databases are as follows. We have graph databases to the right, which we'll get into later. They're used mostly in social media, that kind of stuff, and fraud prevention. Inverted index, hierarchical, which I'd be stunned if anyone who comes across in the wild anymore because they're pretty old. Document stores, key value stores, object-oriented, time series, and there's other types out there. The relational database has what is known as constraints. These are rules that determine how the data can be stored, and the data needs to fit in these columns and rows. And these constraints provide what's called data integrity. They prevent problems like we see on the right here, where we have an age column, which is supposed to be numbers, integers, but somebody wrote the word 19 in there. Well, 19 is technically correct for an age. The computer does not read 19 as a number, it reads it as a string, and it gets confused, okay? So but by having these constraints in a database, you can't type it in there. If you try to type the word 19 into that age column, it will kick back with an error because we put constraints that only allow you to put certain data types in place. Now, however, it's important to note that some data does not easily fit into a single row or column. So to fill that gap, our unstructured databases were created, and they are designed to handle data that doesn't really fit neatly into a model, such as your pictures, audio files, videos, computer code. Okay. So again, another way I pointed out to look at structured versus unstructured is thinking about SQL versus NoSQL. SQL, or structured query language, is the language developed to work specifically with relational databases. NoSQL, which also stands for not only SQL, is not a language, but instead a generalized description for non-relational databases. And it's just like everything else in life, there's a crossover and a split that always isn't easy to define. a lot of the new SQL stuff coming out is adding SQL functionality. Like Google's BigQuery adds a lot of NoSQL functionality, non-relational functionality. But for this class and for just general conversation, SQL equals relational, NoSQL equals non-relational. And remember, NoSQL just stands for not only SQL. It is not an official language or nothing. Okay. So why do we need databases? Databases do more than just store data. Okay. A database is the structure behind the database, and the data model prevents data stores from becoming just another junk pile. Okay. A lot of databases I've been into, it just looks like somebody took a bunch of Excel files, threw them at it, and nobody organized anything. It's almost impossible to go through. So a well-designed database, make sure your data is stored in a secure location. It's easy to query, it means ask questions of the data. It's easy to update, delete, alter. It's easily backed up and restored in case of a disaster. It's easy to secure and prevent inappropriate data access. And it's easy to be exported out of the database to be used by other applications. So, structured databases are designed to prevent issues like the ones seen above. Look at the column in each table above. Each row is specifically repeating the same information, just spelled differently. As a human, we can realize this is all the same person. This is Bob Allen, Robert Allen, living at 123 Main Street in Dallas, Texas. However, the computer would not recognize these things. They are not the same. So, what we do in databases is we will take these, we'll lock them into separate tables to prevent any kind of data duplication, as we call normalizing. We'll get deeper into this. This is one of the big concerns that we have with relational databases. Okay. So the benefits of a database. We have structured data management. Databases organize data systematically, and we can even accommodate unstructured information. Efficient access and modification, improved user monitoring and security, and support for websites, application, and games, because everything you use out there runs on the back of a website. Amazon, your video games, all of them, they all have a database sitting in the back end they run off of. Okay. Uses of database in business and science. I typically break it down into these three uses. Transactional, analytical, the two most common you will see, and computational, which unless you work for research or in special scientific things, you're probably never going to see one of these. Okay. So transactional focuses on daily transactional activity. Think of your grade books, patient charts, inventory management, cash registers. They're designed to be written to constantly throughout the day. For that case, they need to have fast writing speeds. Analytical, on the other hand, they are information resulting from the systematic analysis or data statistics. So they are data warehouses. They are your business intelligence solutions, dashboarding, predictive analytics. They're used in artificial intelligence. And if I could spell it right, it would be even better, wouldn't it? There we go. Okay, nice. And then we finally have our computational databases. These specialized databases handle massive calculations. Think industrial applications, academic research, scientific research, finance. Here's some, apparently I had a typing problem. I put this together. Here's some relational databases that are popular out there. Oracle is probably the most popular. SQL Server is what we're using. MySQL, which is a free one, another great one to use. Teradata, IBM DB2, which has been around forever. Google BigQuery, which is kind of the new kid on the block. It's a couple years old. All right. While the names in the slide may look familiar, they're the first names people think, but they are not databases. These are what's called relational database management systems, or your RDBMSs for short. Remember, the databases is the collection of tables. This is a management system. They are software suites that are designed to create, store, manage databases, run everything from your backups to your security to user access, all those things we're going to play around with, and you'll see within SQL Server. And say in this course, we're focusing on SQL Server as our RDBMS, but the concepts discussed are easily transferred to any other RDBMS. Okay, so again, these are databases stored in this instance of SQL Server. So I have these three, and a database holds a group of tables, few as one up to thousands or even millions of tables. I mean, some of these databases do get enormously huge. Okay, tables themselves hold data that can be accessed through the use of a special program language called SQL. Structured query language, you'll get into it, but SQL is if you're a programmer, you're actually I think you'll enjoy SQL because it's uh, very easy to, very human readable. Okay. So in this case, what we're doing is I'm saying I want to select 3-column script name, date stamp, and runtime from a table called Python scripts. Again, don't worry about this first part. We'll get into that. Our main words, keywords are selecting from, and this gives us our output of the data. Okay. So again, if you really want to know the beginning part, this DBA is our database, DBO is our schema. We'll get to that later. And Python scripts is our table name. And here I want to note that, well, sorry, let me move this so you can see it. You know, no, not all of these square brackets are required. Microsoft SQL Server asks them by default. I'll explain when you can use, why you'd want to use them later. Okay, but that's just a default from SQL Server. I didn't put that in. Okay. Now, relational databases are stored in two-dimensional tables, again, made up of fields and rows. Each record represents an entity of sorts. The table above shows a run date of an automated script. This is the name of my script. This is the timestamp it ran. This is the amount of time it took to run. So that's when it started, and it's how long it took to run. Each field or column is a shared data type. So the date stamp in the date stamp time column is a date time column, while script name is a variable or a string. I can't put a varchar in the date stamp column and back and forth. Again, that is designed for data integrity purposes. That's our constraints that allow us to not have the wrong data in the wrong column. And these tables make up the building blocks of modern databases. Okay, tables are related by common columns or referred to as keys later. We'll get into that. As seen below, we have an employee ID column from one table that matches a manager column from the other. So these are two different tables, to make, just to try to make this a little easier. So these are two different tables. Okay. So what we've got here is I have this employee column here, and I have a manager. I have some departments. So these columns right here, your manager and your employee ID, they are a key pair. So these are our related tables. Okay, this is called a primary key. This is called a foreign key. You'll get so sick of keys that you're gonna get used to it. But as you can see here, I can look at this table here and say my department finance has a manager of 1, 2, 3. Well, I can go to my employee table and see that 1, 2, 3 is Daphne. Same thing, Exmora. So this goes back, and this helps us with our problem we had up here. If you go back to our buddy Bob, Mr. Bob Allen. See, Bob Allen, you can spell his name so many different ways wrong if you kept putting it in each time. But if you just use a key to where the name is only entered in the database once, as seen here, we can't mistake. There'll be no misspellings of Zamora or Garrett or Daphne because they are only listed once in this table. Okay. So now let's focus on the building blocks of the table. So for tables have fields and records, also known as column and rows. Fields are very much like variables in Java or Python. They are assigned a data type, which defines what kind of data can be stored there. While there are many data types out there, there are some examples that are, we could find here. And some of the earlier ones are, we have like an integer here, int, which is an integer. Integers are numbers without anything behind the decimal. Here's our decimal, where the P, you do decimal, you would use P and S, so you'd have precision, and S is your scale, your digits after the decimal. So if you put in here 8, 2, you can have a number up to 8 digits long, and up to 2 of those digits can be behind the decimal point. Varchar, it's a variable string. The X is just the number of characters you can have. Bit, Boolean, it's our true or false. Date, it's date time, our format of month, day, year. That's the value. And then date time, which you'll see here is in year, month, day, hour, minute, seconds, down to thousands of seconds here. But there are a lot more out there. These are just some of the common ones I want to introduce you to. Let's see. And once columns or fields have been assigned a data type, you cannot place the wrong data into there. This mechanism stopping from the wrong data is called a constraint. You'll hear me repeat things over and over again. I think I've said constraint 6 times already in this lecture. That's a hint. It's probably going to be on the quiz for the test. There are other common constraints you'll come across for fields as well, such as you can have a constraint which a field cannot have a duplicate value or cannot have a null. Now, a null is a special term in computer science. It does not mean 0. It does not mean a blank space. It means there's nothing there. 0 and blank spaces are something. A null is the absence of anything. Okay. So now that we have a basic understanding of what a table is, go ahead. We're going to learn some SQL. I'll see you in the next class.